Hello, good day. You are in this virtual class. We'll be looking at binary operations, how to obtain the identity elements in a given binary operation, as well as the inverse elements. So from here, the operation is defined by P asterisk Q is P plus Q plus 3 times their products. 3 times their products. And for us to obtain the identity element, we replace Q with the identity element, which usually, in most cases, represented with the letter, small letter E. So what the definition here is, finding the identity element simply means that this operation here, P operated upon the identity element, is the same thing as the identity element operated upon P is equal to P. Okay? Now, what you usually do here, if you pick this, you say P plus P asterisk E. Now, in place of P, I will still P. In place of Q here, we'll replace it with E. In place of P here is still P, then in place of Q is E, and everything must be equal to the element, the first element here. So now you will have to solve this part, which means P plus E plus 3PE, okay, is equals to P. Now, since we are looking for E, the identity element, we'll move this one to this right hand side, so this will become E plus 3PE is equals to P minus P. Then that means this one is off already, becomes 0. Here we could see that we are looking for P, so we factor out P because P is a common factor here. So E is a common factor, so we factor out E here. This become 1 plus 3P is equals to 0. To obtain the identity element, divide both sides by 1 plus 3P, 1 plus 3P. So the identity element here is 0. Now, without the identity element, there's no way you can find the inverse under P. And to obtain the inverse under P, the simple clarification here is that here it simply means that P, okay, the inverse element means P. We represent the inverse with this is equal to P, the inverse operated also upon P. It must be equal to the identity element. Okay, so if we pick this P operated upon the inverse under P, it become the expression that defines it is P. So in place of Q now, we represent it with the inverse plus 3P, P inverse is equals to the identity element, and the identity element here is 0. Okay, so here the expression or the equation become P plus P inverse plus 3P times P inverse is equals to 0. So let's move P to the right hand side. So we have a P inverse plus 3P times P inverse is equals to 0 minus P, that gives minus P. Then we are looking for the inverse, so we need, and the inverse here is has a common factor, so we factor it out as P inverse into 1 plus 3P. So if you look at this the term here, P inverse is common. So the P inverse is common, so we factor it out is equals to minus P. Then to obtain the inverse, this becomes P inverse by dividing both sides by, divide both sides by 1 plus 3p, so that eventually the inverse become minus p divide 1 plus 3p. Okay, so this is the inverse of this operation. So the question, the last question says that find the value of p which belongs of a member of real number for which no inverse exists. Now for this expression, if no inverse exists, it simply means that the denominator here must be equal to 0. Okay, so the denominator of the expression here, which is 1 plus 3p is equal to what? 0. You know, because in algebra, if an expression, okay, does not is undefined, okay, it simply means that you equate the denominator of the expression to 0 and solve for the value of the unknown there. Whatever value that you substituted to make the denominator to become 0. In that case, we know that 3 over 0 is undefined. I mean, does it exist at that level? So let's find the value of p at that point. So here we move 1 to the other side. This is plus, it become minus 1. Of course, we get p there. P is equal to minus 1 divided by 3. So ensure that we are dividing both sides by 3, just to obtain here. So if you substitute 1 over 3 in place of p here, this expression become 0. So this is the value of p at which there is no inverse is when you have a minus 1 over 3. Please, if you find this video very useful, please help me subscribe, follow my Facebook page, Mathematics, and if you have any comments to drop on how I can do it much more better, please do not hesitate. See you in my next virtual class.